And we are recording, and you should be able to see my screen. And we're going to get going. Of course, that's a bonus question. So he takes the highest grade and drops lowest. All right, here's an NPX. So we're going to pull up our handy dandy calculator. Now, how do I know it's not mean and standard deviation? Because it says compute the what? The probability. Now, it also says a binomial probability experiment. So therefore, you're going to do NPX. So we take our handy dandy calculator, which I thought I pulled it up. Where is it? Oh, I know where it is. Let me get, there it is. Now, I looked, is Miss Hicks in here yet? No. I looked for her calculator and I could not find it. I've got a TI 84 plus CE. That's what she said she had. And I tried to get it to do what it was pulling up. I've seen calculators pull up the left, right tail. I've seen that, but I can't get it to work on this one, so I don't know. So anyway, on this one, you hit second vars, go down to binomial. This one is precise because it's equal to, so we're going to do PDF. And the number of trials is 8. P is 0.45. And X is 4. And if you have an older calculator, when you hit binomial PDF, it'll give you a parenthesis right here. And then you type in 8, 0.45, 4, and then parentheses. So depending on how old your calculator is, you're going to have one of the two. Hit enter and round to 4 decimal places because it is area 2627. So that would be, wait a minute, it says do not round. Round final, okay, 4 places. So that's going to be 2627. 0.2627. And that should be correct. Next. Assume the random variable is normally distributed with a mean of 50 and a standard deviation of 7. So that means we're going to our handy dandy, whatever it's called, document cam. Okay. So I'm going to minimize this, make it smaller. So we know that M is 50, or 50 in the middle, and that's going to be 57, 64, and 71. If I do my math right, somebody check me, please. 50 minus 7 is 43. And this is where I get kind of shady. 43 minus 7 is 36. Somebody help me out. And 36 minus 7 is 29. So somebody check on your calculator and make sure I did that math correctly. And it says they want to know the area between 57. Let me use a pink highlighter here. 57 would be right in here. And 67. We don't have 67. So we got to find it. So 64 to 71, half of 7 is 3.5. So 67.5 would be right there. So 67 is going to be right here. So they want to know the area between 57 and 67. Now, if you got a new calculator, you don't have to do anything. If you've got an older calculator, you're going to have to find the z-score for 57 and 67. 57 minus 50 over 7, and 67 minus 50 over 7. And that's going to be 1. That's your z-score there. And then here, we don't know because it's between two z-scores. So I say it's going to be around, let's see, this is 1, 2, 2.5. I'm going to say it's going to be around 2.4. So 67 minus 50 is 17. And 17 will go in there 2 times. That'll leave 30. 2.4, 28, 20, I think 2.43, but somebody check me, please. What is 17 divided by 2?
It's 2.428.
Okay, well, if we round it to 2 decimal places, 4.3, because z-scores are 4.3. So there's your second z-score. If you've got an older calculator, then you would do second, vars, and normal CDF. And then you would go from 1 to 2.43. This is if you've got an older calculator. Because the older calculators, you can't change 0 and 1. Okay, I'll show you both of them. So there is my 0.1511. So that area in here is 0.1511 or a 15% chance. So let's check it with a newer calculator. With a newer calculator, you would type in normal CDF, and then you would type in 57 and 67 with a mean of 50 and a standard deviation of 7. And you'll see it's going to be the same answer. A little bit more detailed because of the rounding. When you round, that's when you divide that 2.43, like you said, Miss Griffith, I think you said, it would be 2.428 or something like that. In other words, there's a little bit of difference between the two numbers because of the division of that 17 divided by 7. Everybody good there? So 0.1511. And 57 to 67 be that one. 0.1511, and that should be the correct answer. Next, United States. Assume that the random variable x is normally distributed with a mean of 80 and a standard deviation of 8. This right here says draw the curve. When it says mean and standard deviation, that means draw the curve. I've been saying that for a while now. So I've got a mean of 80 and a standard deviation of 8. So that'd be 88, be 96, and I have no idea, 104 or 114. Let's see, 8, 104. Subtract 8, that'd be 72.
Priority 1 message coming
Subtract
in on secure
8,
channel.
64. Subtract 8, 56. Somebody help me out there and make sure those are correct. All right. Now they want to know what is the probability of the less than 90. So 90 is going to be right in here. Let's see. What's between 8? That's 4. So that's 92 right there. So halfway between 82, 88, 90, that's 90 right there. So I'm going to draw me a line on 90. And they want to know what is the probability of being less than 90. Well, less than 90 is right there. And don't forget, this arrowhead down here is called negative infinity, or negative 9999. So if you have a new calculator, newer, you don't have to type in that much. I mean, you have to type in whatever they give you. If you've got an older calculator, you got to turn 90 into a z-score. 90 minus 80 divided by 8. 90 minus 80 is 10. 10 divided by 8 is also 5 over 4. And 4 will go into 5 one time. That'll leave 0, which is 10. 1.5. Somebody check my math. No. No, that's not right. Let's see, that's going to be 1 and 1 left over, 10. How about 1.25? Somebody check my math there. All right, so my z-score for 90 is 1.25 if I have an older calculator. Now, this is, and you can use negative 9999. It doesn't matter what you use for negative infinity. I mean, it's pretty, you can use 10,000 or you can use 850, negative 850 if you want to. So pull up my handy dandy calculator. And I'm going to do second, bars, and go to normal CDF. And I'm going to go from negative 9999. And since somebody might have an older calculator, I'm going to do the older calculator first. It's going to be 1.25. Mean is 0. I can't change it on an older calculator, so it'll stay like that. And hit paste. And that's what it would look like on a older calculator. When you type in normal CDF and it just gives you the parenthesis, then you type in negative 999, negative 9999, negative 99999, negative 10,000, whatever you want to punch in, comma, 1.25, comma, and then 0. I'm sorry, negative 9999 and 1.25, and then close parentheses. Usually on the older calculators, they don't ask this because you can't change it. And that's one of the reasons, you know, that's the difference between the older calculators. Anyway, enter, and it's 0.8944. So this area right here is 0.8944, or 89.44%, or 0.8944 probability, however you want to say it. So since 0.8849 is the closest, we'll go with that one. I'm sorry, this one. I'm sorry, I didn't even see that one. And enter, and that's correct. Okay, make sure you holler any questions if you got them. Okay, A random blah, 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 blah. Use the probability distribution table below to find the mean and standard deviation of random variable. Now, before we even start, I'm going to change this because this is not the way I showed you a table should look like. I told you that the tables would look like this. So I'm going to fix it. X, P of X, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And I'm going to change those fractions because I showed you decimals, so we're going to change them to decimals. I'm going to have to use the other calculator if y'all don't mind. Well, there. So 3 divided by 17. 0.1765. 0.1765. 5 divided by 17. Now, while you're also doing this, you want to check, make sure all of them are between 0 and 1, which so far they are. 2941. 2941. 6 divided by 17. 6 divided by 17. 0.3529. 2 divided by 17. 2 divided by 17. 0.1176. And the last one, 1 divided by 17. 0.0588. Now, the good thing about fractions is when you test to see if they equal to 1, it's easier with fractions. 5 plus 3 is what? 8. 8 plus 6 is 14. 15, 16, 17 over 17 is 1. So it does check, and this is your probability distribution that you're going to work with. Now let's see what the question asks. Use the probability distribution to find blah, 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 blah. The mean. Okay, well, we got to find the mean and the standard deviation. So remember the formula for the mean. Mean is equal to the summation of x times p of x. And the standard deviation is equal to, or sigma, is equal to the square root of the variance, which the variance is the summation of x squared times p of x. And then that's in brackets, minus the average squared. Now, we did this in class, so don't act like you've never seen it before. I'm going to pull up the Excel spreadsheet because that's the easiest way to show you how to do everything on the limited screen area that I have. Not that you have to learn how to do Excel. It wouldn't hurt, but this is the best way to show you in this context, this class format. So I'm going to make it a little bit bigger. I'm going to call this X. I'm going to call this P of X. P of X. There we go. And make sure everything is centered. 0, 1, 2, 3, 4. 1765. 0.2941. 0.3529. 0.1176. And 0.0588. I'm going to make this a little bit bigger because I want it to have 4 digits. So And of course, if you want to use your handy dandy calculator, you would pull it up and you would hit Stat, Edit, and type in 0, 1, 2, 3, 4. And 0.1765, 0.2941, 0.3529, 0.1176, and 0.0588. And over here, we're going to do x times p of x. X times p of x equal to this times this, and copy that down and add it up, and mean is equal to, oh, I hate it when it does that. Okay, summation. Now somebody tell me what else could the mean be called in 6.1 or 6.2 material? What else could it be called, like with the life insurance policy? What could it be called? Hello? We went over that life insurance policy 2 or 3 times. Starts with an E. X. P. E. C. Oh, come on, people. Did y'all not write the notes down on the life insurance policy? Are y'all not going to talk to me or what? At least tell me that you're there.
I'm not entirely sure.
Okay. Well, thank you for, I appreciate you interacting with me. Thank you, Miss Griffith. Nobody's heard of the expected value. I know you've heard of it because we did it. Remember the life insurance policy? Okay. Okay. You're not going to talk to me. That's fine. The expected value is also called the mean, but y'all not going to talk to me, so I'm not going to worry about it. All right. So that's equal to 1.5879. And now I'm going to do x squared. And that's going to equal this number raised to the second power. And I'm going to copy that down. And then I'm going to open this up and do x squared times p of x. It's going to equal this number times that number. And Control C, Control V. And the standard deviation is going to be equal to parentheses this guy minus this guy to the second power. And I'm going to raise all that to the 0.5 power, which means I'm taking the square root of it. Raised to the 0.5 power. And that should be your standard deviation. 1.087876. Now, if you use your handy dandy calculator, you hit Stat, Calculate, First Variable Statistic, type in L1 and then L2, second, 2, and calculate. There's 1.588, which is your mean, and your sigma is 1.0878. So there's your answers, X bar and 1.0878. So let's go back to the question. And I think it's going to be D as in delta. Next. Okay, is this a normal distribution? Looks like to me it's normal. I need to take that one off the test. Somebody will get it wrong, don't worry. All right, do this one. Draw a picture. Oh, me. Assume blah, 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 draw a picture, blah, blah, blah. All right, so here is my 50, 57, 64, 71, 40, 36, 29. And they want to know the area or the probability that a number is going to show up above 42. So and if you have an older calculator, you're going to have to change that into a z-score, minus 50 over 7, which is equal to, that's 9, negative 9, let's see, 8 over 7, which is equal to negative 1.114. Somebody check me on that, please. What's 8 divided by 7? Can nobody check 8 divided by 7 for me? What?
It's 1.14.
Thank you. Ms. Griffith, I think you're the only one here this morning. Everybody else went back to sleep. And it says that, oh, I'm sorry, not less than, greater than. My bad. So we'll do greater than in green. P of X being greater than 42. So that's this side. So if you have an older calculator, you would do from negative 1.44 to, this is positive infinity, which means 9999. If you have a newer calculator, you just type in all the numbers that's in the question and they would spit out an answer. So let's go ahead and I think it's going to be this one. And let's go ahead and take our handy dandy calculator and go second, bars, normal CDF. And I'm going to stay with the older calculator. That way it covers everybody. So that's going to be negative 1.14 and 9999. And of course, if you have a newer calculator, you would type in 42 right here, and you would type in 50 and 7 right there. 0.8729. So this area in green is 0.8729. So therefore, just to show you, the pink would be, well, let's see, 1271, which is the complement of 0.8729. Oops, I'm sorry. Hold on. Since I accidentally drew the pink in there, I figure I might as well do the complement. So 0.8729, the complement of 0.8729 is 0.1271. So since I did draw the pink on there, I went ahead and did the area for it, which is the complement of the right-hand side. So 0.8729. Check it. And that's correct. Next, and cell phone. Next, NP. This is cumulative. Why is it cumulative? Somebody tell me, why is this one cumulative? Okay, I'm going to ask somebody. If nobody answers, I'm going to ask somebody. So I hope you're going to answer. I'll answer one more time, except for Miss Griffin. You already answered twice this morning. What tells me that this is cumulative? All right, Mr. Passetti, what tells me that this is cumulative? I think people are going back to sleep. Miss Bailey, what tells me that this is cumulative?
Sorry, I'm driving to the campus. Can you repeat the question?
That's fine. That's fine. I don't mind you driving to campus. What makes this problem cumulative? Just look. It's right in here. It's right in here.
Is it because it's not inclusive? Like
exactly. It's less than. Good job. So you would hit, instead of, you're not driving also, are you? Good gracious.
Yes, I'm driving right now.
Okay, well, I don't want you to have a wreck. You just keep doing what you're doing. Okay, is it already close? Okay, all right. Okay, here we go. So that'll be, instead of normal CD, I'm sorry, instead of binomial PDF, this is going to be binomial CDF. So second vars, go down to binomial CDF for cumulative. Trials is 9.35. And tell me what I'm going to type in for X. Am I going to type in 4, or am I going to type in another number? What number am I going to type in for X value?
A number.
Miss Yates. Okay, Miss Griffin, what?
A number less than 4? Does it have to be?
Which is what?
3.
3. And paste. And that's going to be 0.6089. 0.6089. Okay, this one is asking you, is this a probability distribution? Is there any negatives or whole numbers? Nope, so that's good. Now somebody add those up for me. 17 cent and 25 cent is what? 42 cent, 42 cent, 58 cent, 80 cent, and 20 cent. I got it. I got one. Somebody check that on the calculator. Okay, thank you. So it's going to be Charlie.
I got one.
Okay, good. Thank you. According to a report, 53.6% of murders are committed with a firearm. So that means that 46.4 is committed with knives, forks, spoons, slingshots, cars. That's interesting. If 300 murders are randomly selected, how many would we expect? Okay, now what is the difference in this one? This one is NPQ. Why? Because they don't give you enough information to do NPX. That's why. This one is NPQ. Mean is equal to NP. And the standard deviation is equal to the square root of NPQ. So P is equal to 0.536. And N is equal to 300. Now, just to save time, I'm going to use the handy dandy calculator. And I'm going to do 0.5360 times 300. And that's equal to 160.8. So the mean is equal to 160.8. And the standard deviation is going to be equal to the square root of 160.8, which is NP, times Q, which is the complement of this, which Q is equal to 0.4640. I think that's right. Somebody check me. I'm just going to ask Miss Griffith to check me, please. And that's going to be, so I'm going to take that number and I'm going to multiply it by 0.4640. Did you check it? Well, now she's driving somewhere. And raise that to the 0.5 power. And that's 8.637777492. 1, 2, 3, 4, 4 sevens. 1, 2, 3, 4 sevens. And we would expect, there's that word again, expect. The average is the expected value. It doesn't say round, so we're going to do 160.8. Well, you can't have a 0.8 of a crime, so I'm going to say 161 crimes. Okay, now let's look at, it says draw a picture right here because they want to know 2 standard deviations. That's what this means right here. So I'm going to draw a picture. As soon as I could find my hold on a minute. Trying to pull everything up and I'm hiding everything, so just give me a second. Okay, well, there's the question. I'm not going to try to waste time. So I'm going to draw a picture. And 160.8 is in the middle. So 160.8, I got to use the calculator. It's got a decimal. So 160.8, 160.8 plus 8.64. 8.64 is 169.44 plus 8.64, 178.08 plus 8.64, 186.72. I'm going to subtract because I can't remember what the question's asking. 160.8 minus 8.64. That's 152.16 minus 8.64. 143.52 minus 8.64. 134.88. And the question says, $161, and would this be unusual? Would it be unusual for 184 murders by firearms to be happening with 300 murders? Would it be unusual to observe 184 murders? Well, 184, let's go ahead and put we know that this 2 standard deviations, and we've been doing this from the beginning of the empirical rule, which is unit 1. Okay, so I don't want anybody acting like they don't know what this is. That's normal. And then this is unusual. And then the outside is what? The outlier. Unusual and outlier, that's pretty much the same thing. One's more extreme. And let's plot 184. 184 is right here. Is that unusual or normal? Unusual. So it would be unusual because it's outside 2 standard deviations. So yes, it would be because it's greater than 2 standard deviations. Next, find the area under the curve to the right of z is equal to 1. Okay, this is just a normal curve. We want to know this area. That's infinity, and that's 9999. So mean is equal to 0. Standard deviation is equal to 1. So let's put it in the calculator. Second, bars, normal CDF is 1 to 9999. 0.1586 or 0.1587. So that's your answer. The probability that an individual has 20/20 vision is 0.12. In the class of 50 students, what is the mean and standard deviation NPQ? Why is that NPQ? Because you're not giving any other information. So NPQ N is equal to -0.12. No, it's not N. N is equal to 50. And P is equal to 0.12. Therefore, Q is equal to 0.88. And the mean is equal to 50 times 0.12. And the standard deviation is equal to the square root of 50 times 0.12 times 0.88. So get your handy dandy calculator. And that's going to be clear 50 times 0.12. So mean is equal to 6. And the standard deviation, 6 times 0.88. Raise that to the 0.5 power, or take the square root of it, 2.29. I'm going to go ahead and say 2.3. So 6 and 2.23, or 2.3. Mean is equal to 6. There we go. Next, the only one that you can answer correctly, the only realistic answer. The length of a particular animal's pregnancy are approximately normally distributed with a mean of, draw the curve. That's what it says. The length are normally distributed. Draw this curve. That's what it says. Now, I'm not going to go through all of these because I think I should show you the answers. So I'll start it, and we'll do at least A. So the first thing I'm going to do is get me a picture, and 275 goes here. And then our other numbers, 275 plus 8. I hate adding 8s. 275 plus 8. 283. 283 plus 8. 291. And 299. 5 minus 8. Minus 8. Minus 8 be 251. Okay, so there's my question. Now, what is it asking? Well, I'll do the first one, and y'all can do the rest of them. Okay, so I'm gonna leave it right there. What proportion of pregnancies last more than 277. So I'm going to plot 277. And more would be to the right of 277. 277. And of course, if you have an older calculator, minus 275 over 8. So I'm going to do that on the calculator right quick. I know we're running out of time, aren't we? Yeah, let's see. Yeah, we're out of time. Okay, well, anyway, that's how you do that problem. Everything's based on the curve. And you've got 2 days. I've ran out of time, and I'm sorry, but that's pretty much it. And I think I covered at least 5 or 6 questions the other day. So that takes you up to 26, 20, 25, 26. So I think I've covered enough for y'all to finish this test. Okay, let me get the roll. And somebody left. Did anybody see who left? Somebody left. Okay, nobody's going to talk to me. It's wonderful talking to y'all and conversing with y'all. It's just great.
I think it was Bailey. She said she was driving to class.
Who was that?
Her last name is Bailey.
Okay, thank you. Well, I'm trying to get, okay. Gotta love Tri-County Tech, logs you out in 15 seconds.